Okay, well, 5G is not much of an interest of mine. I was looking at that Mark Steele video the other day where he's wandering around Wickham saying how dangerous the radiation levels are. He's using one of these devices, the EMF meter that he was using. It measures from 50 megahertz to 3.5 gigahertz. $129 US. So as I said in the previous video, we're not talking about a piece of professional test equipment here. But let's just have a little look at what this thing does, and then we'll have a little look at what Mr. Steele might have actually been measuring. Okay, so let's get this down here. It says this broadband EMF RF field meter, field strength meter for monitoring high frequency radiation within the 50 megahertz to 3.5 gigahertz measuring range. It's designed to measure the electromagnetic field value of the radio frequency. Okay. Can do non-directional isotropic measurements. So that means radio signals are polarized, vertical, horizontal. They can be spherical. A lot of FM stations use spherical polarization. What that means is that whether you're in your car using a vertical antenna, or whether you're at home using a horizontal antenna, if you're using a portable radio with a slanted antenna, in a given spot you'll get the same field strength regardless of the orientation of the antenna. So let's have a look at, it's got a configurable alarm threshold. This computer is driving me crazy. Where's the left hand clicker? It's not in the center of the computer, this bloody thing. This is an Acer computer. It drives me crazy. I can never find the right clicker. Okay, applications. High frequency RF electromagnetic wave field strength measurement, mobile phone base station antenna radiation power density measurement, RF power measurement for transmitters, wireless LAN, Wi-Fi, spy cameras, wireless bug finder, cellular cordless phones, Bluetooth, microwave oven leakage, personal environmental safety. So it does 50 megahertz to 3.5 gigahertz. Non-directional high dynamic range due to its 3-channel digital result processing. So that's going to mean that it looks at 50 megs to 3.5 gigs because it's a very wide bandwidth. It's probably got 3 separate amplifiers that are doing that. The output of those will be combined to give you a reading. Configurable, alarm threshold, measurement range. 38 millivolts to 11 volts per meter. Didn't he say he had 9 millivolt per meter reading? That's out of that range, isn't it? But anyway, let's have a look. So there we go, measurement units. There's all the measurement units. Display resolution. Oh, okay, so you can have 0.1 millivolts. Okay, so on the lowest setting, he can read millivolts. Oh, he can read microvolts. Okay. Directional characteristics, measurement range selection. One continuous range. There you go. So that means that he can't select the 5G transmitter frequencies only to measure. The measurement range selection, one continuous range. That means it's one continuous range between 50 megahertz and 3,500 megahertz, 3.5 gigahertz. Okay, you can't look at just little blocks of that. It looks at all of it and it gives you a value. Instantaneous measured value. Okay, so that's the device. So he can't use that device to look at the individual 5G transmitters. So when he's wandering around Wickham and he's waving this thing around and he's saying that it's dangerous, it's causing cancer and all this sort of stuff, he's waving this device around. $129. What he's looking at is the combined signals from the television broadcasting, FM broadcasting, Wi-Fi, mobile phones, public radio, utility radio. All that is within that range. Okay, so let's just have a little look at what he might have actually been measuring. Now, the broadcasting for Newcastle comes from a place called Pontop Pike. So we go to Pontop Pike. Okay, Pontop Pike. Now, as I say later on, if I can find the left-hand clicker, from there to there, 5.69 miles. I think it was 6 and a bit miles a little bit later on in the video, but it's no distance at all when you consider the sort of power levels that are being used from Pontop Pike. Let's just have a quick look at Pontop Pike. The broadcasting transmitter site. Just zoom in and have a bit of a quick look at it. Might want to go and sit on that road there, Mr. Steele. That'll scare you to death, that's for sure. There we go, Pontop Pike. So there's Pontop Pike transmitting station. That's probably a shadow on the field there. But you can see it's a fairly significant broadcasting installation. There's a lot of high power transmitters there. Only, I think I said 5.8 or 5.6 miles was it. The other line I drew was between there and Wickham. Might have been somewhere else in Wickham, but that was 6 and a bit miles, depending on how big Wickham is, of course. Well, you know, the line can be a different length, but we'll call it, say it's 6 miles. And if we go to this chart, now, when analog television was shut down, the television band was made available for mobile phones. Okay, so the frequencies that are being used for 4G, 3G are analog television frequencies that were freed up when they were moved onto the different frequencies for the digital services. Now, if we have a look at, so this is Pontop Pike. This is what was running at Pontop Pike, the 500 kilowatt transmitters for BBC One, BBC Two, ITV, Channel 4. So that's 2 megawatts there, just those. And if we look at the channel numbers, there's channel 64 there. Is the highest channel number. So normally highest channel number means highest frequency. So let's just see what frequencies we use for channel 64. So we go to our chart. Channel 64. There we are. So 815.25 megahertz for the vision, 821.25 megahertz for the sound. So up into the 800 megahertz region as you go up in channels. And these are all television channels here. So channel 69, which was the highest frequency of the TV channels, 855.25 for the vision, 861.25. So before digital television started from Pontop Pike, you had 500 kilowatts being radiated just 6 miles away from Wickham on 815.25 megahertz, 821.25 megahertz, and there was the other 3 channels as well, all within a similar region. All these UHF TV channels, they're all in that block there, and they were all 500 kilowatts each. Okay, all right. Well, let's get back to Google Earth. we can see that Pontop Pike is, the Pontop Pike transmitting station is there. Okay. And Wickham is there. So let's just draw a line between Pontop Pike and Wickham, and we'll see how far it is, and then we'll have a look at what sort of transmitters are running at Pontop Pike. Now we'll remember that Mr. Steele has been talking about 25 milliwatt transmitters. 25 milliwatts, that's 25 thousandths of 1 watt. Okay, so let's go to there. There is our Pontop Pike transmitter, and we go there to Wickham. Okay, so there we go, there's Wickham. That's where Mr. Steele was taking his measurements, and where that is, that little pin thing is Pontop Pike. Now we can see that's a distance of 6.3 miles, so it's not much of a distance at all there. And if we run the cursor along this yellow line and look at the elevation, well, let's look at the elevation, and I'll run the cursor along the line. So we're going to be looking at. Hang on, let's just get rid of that. Ah, now my line's gone. Oh dear. Okay, so we go from there to there. Okay, so let's just run the cursor along that. Let's look at the elevation from Pontop Pike to Wickham. So can you see that elevation? 285 metres there. It's coming down as I'm going along the line. 220, 189. It's descending all the way. It's high up on a hill, the transmitting site. 158 metres, all the way to Wickham. So there it is at Wickham. Elevation 120 metres. We move that down to Pontop Pike. ,253 metres. So basically, along that yellow line is downhill all the way. That will be pretty much line of sight, probably. That's 100 metres higher. Certainly as far as the radio signals go, if you were standing on top of the antenna at Pontop Pike, you would be able to see Wickham. Okay, now just before we go to see what sort of transmitters there are at Pontop Pike, well, let's just have another look at. There's another transmitter at another transmitter site at Wickham. Which is only 2 miles away. Oh, actually, no, let's just go to Pontop Pike. Let's just go to Pontop Pike. Okay. So, these are the current transmissions from Pontop Pike. Remember, Mr. Steele is talking about 25 milliwatts, 25 thousandths of 1 watt. So this is the current transmissions from Pontop Pike. So we have channel 58, this is digital TV, channel 58, 100 kilowatts, that's 100,000 watts effective radiated power on channel 58. On channel 54 there is 100 kilowatts, 100,000 watts of effective radiated power on channel 54. On channel 49, 100,000 watts of effective radiated power. Channel 50, 50,000 watts of effective radiated power. Channel 59, 50,000 watts of effective radiated power, and channel 55 there, 50,000 watts of radiated power. That's the television. Now there's also radio from Pontop Pike, FM radio. So we have BBC Radio 1, which is on 98.1, which is 134,000 watts, 134 kilowatts effective radiated power. Remember, Mr. Steele's device measures everything from 50 megahertz to 3,500 megahertz, so this falls well within that. BBC Radio 2, 88.5, 134 kilowatts. 134,000 watts ERP. BBC Radio 3, 90.7. 134,000 watts ERP. Mr. Steele's talking about 0.025 watts from what he says is a 5G transmitter. 25 thousandths of a watt. And here we have 134,000 watts, 134,000 watts, 134,000 watts, BBC Radio Newcastle 95.4, 10,000 watts, Classic FM 100.3, 65,000 watts. Now, what his meter is going to do is sum the energy from every one of these signals, add it together to give you a reading. It's going to add those to those. Yeah, 100,000 watts, 100,000 watts, 100,000 watts, 50,000 watts, 50,000 watts, 50,000 watts. All this stuff. 134 kilowatts, 134,000 watts. You know, all this is at Pontop Pike, 6 miles away from Wickham, where he's taking his readings. And all this is going to be summed together. And the energy from all these high power transmitters are going to be summed together and displayed on his little gadget. Now, digital television, of course, uses a lot less power than the old analogue television. So when the analogue television was running from Pontop Pike, where he was standing at Wickham, up until 2012, look at these. BBC One, 500,000 watts. 500 kilowatts. BBC Two, 500 kilowatts. ITV One, 500 kilowatts. Channel 4, 500 kilowatts. And all this RF energy. Okay, well, let's just have a look at some of these channels, shall we? These are the channels. These are the ones that are operating at the moment. So let's just have a look at, what's that, channel 58, channel 59? Are probably the highest frequency ones. They tend to, you know, go up in frequency as they go up in channel number. So let's have a look at channel 58 and channel 59 and just see what those frequencies are in megahertz. So let's just have a look at that. I think that's this one. Yeah, it is. Okay, so channel 58. Where are we? Channel 58, there we go. 767.25 megahertz. The other one's probably going to be the sound. Hang on, what's this? What is this table telling us here? Whoops. Video carrier and audio carrier. Yeah, okay. So this is the vision, this is the audio. This is the vision. 767.25 megahertz. There's the sound, 773.25 megahertz. There's another one there, what was it, 54, 735 megahertz, 0.25, 741.25 megahertz. And there was a number of channels there that are all within this range. What was the lowest one? What was the lowest one? 50. So if we look at that, what's the lowest frequency they're using up there? It's channel 49. So what's channel 49? Channel 49, of course, it's just off the screen. Okay, so channel 49. Channel 49 is here. 695.25 megahertz, 701.25 megahertz, vision and sound signals. 100,000 watts. Okay, so all of these signals from all of these transmitters are going to be summed together with Mr. Steele's gadget. All this is at Pontop Pike, which is 6 miles away from Wickham, which is why he's getting all those large readings, because he's looking at all these big high power signals. 100,000 watts, 100,000 watts, 50,000 watts, 134,000 watts, 134,000 watts, all summed together and displayed on his little gadget. Now if you just go back to Google Earth, there is a smaller, where is that? If I just go back a bit, go to, what's it called? Phenom. There we go. So if we go to Phenom. Okay, now Phenom is only 2.2 miles, I think, from where Mr. Steele was taking his measurements. And hang on, let's come out of there. Oh, I should have bookmarked where the actual transmitter site is. But if I'll tell you what, if you watch this, Mr. Steele, perhaps you'll go to this point on this road and with your little gadget and take some readings. This is a much lower power. There we go. Now this is at Phenom. It's on the edge of the reservoir up at Phenom. And this is a TV radio translator. There are some more radio stations on this, and there's some television on this. It's much lower power. It's not in the hundreds of thousands of watts. It might be a few thousand watts here, a few hundred watts maybe. But if his gadget is also measuring the signals from this site as well. Included in his measurements will be the signals from this site. And be quite interesting if Mr. Steele decides to go to this road and stand along here with his gadget, you know, near these places here. Measure the field strength there from this broadcasting site. But anyway, so Phenom, we come out from there. Hang on. I need to get Wickham back on here. There we go. So Phenom and Wickham. I get the ruler and I go from Fenham to Wickham. There we go. It's 2.47 miles. So it's only 2.5 miles from one broadcasting site. With much lower power transmitters on it than the main Pontop Pike transmitter, which is 6 and a bit miles away, but still no real distance with those kind of power levels. And so he's going to be measuring all the signals from Pontop Pike. He's going to be measuring all the signals from Phenom, which is only 2.5 miles away. And again, if we look at, if we draw a line, hang on, where's the ruler gone? We draw a line from Wickham to Phenom. We can see, if I move the cursor along that line, let's just move that and look at the elevation. So unfortunately you can't actually see the cursor going along the line as I'm moving it, but if you look at the elevation, so I'm going from Wickham now, 114 metres. I'm going towards the river, as you might expect at the river, which is about halfway, minus 3 metres. It's going back up to Phenom, where the transmitter is, back to there, and that's 115 metres. So from there, and it goes down, it's 115 metres, goes down to 0 there where the river is, and it goes back up to, what was it, 107 metres there. So this is going to be, again, this is going to be a line of sight with regard to the radio and television signals from Wickham to Phenom, across that valley there as it sort of falls away to the river and then comes back up again. So you've got the broadcasting site at Phenom, and I did have a chart there, I don't know where it's gone, but it showed all the television transmitters and FM transmitters that are operating there, and the ones I've showed you at Pontop Pike, which are only 6 miles away. And Mr. Steele's gadget will aggregate, it will combine every single signal from both of those sites and others, Wi-Fi in houses, UHF links from utility companies, and give you that reading. So what Mr. Steele is measuring there is the RF field strength from all of those transmitters combined at that location. So what he's measuring isn't anything whatsoever to do with 5G. He's got absolutely no idea what he's measuring, that guy. Absolutely clueless, Mr. Steele. I don't know what sort of... He said he was a weapons expert. Goodness knows what sort of weapons. Spud guns, probably. It's not going to have anything to do with microwave technology, that's for sure. All right, well, there you go. As I said, 5G, not really much of an interest of mine. I just stumbled across Mr. Steele because I looked at Miles Johnston's channel and I looked at a couple of Mr. Steele's videos, and I thought this looks like a lot of cobblers to me. And very, very little investigation shows that that is the case. There's nothing whatsoever to it. Okay, well, I hope you found that interesting. As I say, it's not really sort of alien ET stuff, but it's just another conspiracy that's floating around out there, and that's what it is. 5G is a weapon designed to kill us all. Absolute drivel, rubbish, nonsense. Okay, as always, if you've struggled through this far, thank you very much indeed, and perhaps I'll catch you again.